Okay, so working on the chapter 1 review. I'm sorry, chapter 3 review for transformations. So go with the first couple of questions. Let's see. So it's describing transformations, and for the rotation, which is this first one, basically what we need is we need to know the center of rotation and the angle by which we're going to rotate it. So looks like the center's about there. And to me, it looks like we're going to go 180 degrees. Okay, it looks like actually that first one's supposed to be a reflection of point. This is the rotation. And let's see. This is the corresponding point. That. Okay. So, not sure exactly where the center is. We'd have to draw two perpendicular bisectors of corresponding points. Get that? All right, it's probably right around there, it looks like. Yeah, that's the perpendicular bisector, that one. Right around there. And so we do need to know the center, and we do need to know the angle that you're going to work with. Okay? For a reflection in a line, you need to know the line of reflection. Since we're looking at two words, I would say you'd have to know what is perpendicular to the line of reflection and the same distance. So the math term we use is equidistant. Okay? So think of a line reflection as the line we reflect through must be the perpendicular bisector of any pre-image to image segment. And that's a key concept. That'll help us with a lot of problems. Okay, so think perpendicular bisector of any pre-image to image segment. All right, so I'm going to go with you got to move perpendicular and the same distance away. All right, reflection of a point, you're simply going to need to know the midpoint. Okay, so that's this one. All right, so this point travels there. You got to know the midpoint. Okay, the reflection of the point is going to be the midpoint. So I don't know what the other word is looking for, so I'm just going to call it a reflection of the point as midpoint. Distance might help us. I'm not sure what they're looking for there. As far as translation goes, you do need a distance. Okay, whoops, wrong one. You need a distance to travel. Say that's A and A prime, and a direction. So I'm going to go with distance and direction. Now, what I try to tell my students is the concept we used in geometry for this was directed segment. In science, they're going to use vector. Okay, so that's kind of what I relate to translation as directed segment. All right, let's keep going. All right, we're going to go back to point A for every one of these problems. So I put a few graphs there to get ready for it. So here's 2, -4. Label it A. A reflection line y equals x. Okay, so they start right off with a tough one. So the line y equals x goes, I wish I had a straight edge here, but can't use it when I'm this. Basically, this is your line y equals x. It's hitting all of these. I'm basically trying to go down one, left one, or up one, right one. You know, you're trying to do that slope. Okay? Now, the slope of this line y equals x is up 1/1. Now, what do you do from A to get its image? Well, I always teach my students to go with the path first, without getting the path down first. What path is A going to travel to get to A prime? It's going to be perpendicular. Now, perpendicular to y equals x, use a slope, right, that's -1/1. So down one, sorry. So we go down one, right one, or up one, left one, and that's the path that A is going to travel on to be perpendicular to the mirror. So I teach my students, draw that path first. Okay, just draw the path. I'm going to go this way. Now, after we get the path down, we'll count the squares. So start here. That's 1, 2, 3 diagonals. So let's do it again. 1, 2, 3. And that's where A prime is going to land. There is another rule here. Okay. You could just switch the coordinates, -4, 2. Okay. Does work. Now, the reflection line y equals x. I'm going to go to a different graph here, but I won't do this for every single one. Okay. Just gets a little messy here. Here's the line y equals -x. Okay. You're going down 1, right 1 from the center, from the origin. I'm not going to draw the whole line. That's y equals -x. All right, and then we're going to move perpendicular to the line, right? Perpendicular. Okay, now it's going to take one diagonal to get to the line, so right there is a double prime. Okay, so that is going to be the point 4, 4, -2. So a double prime we'll call 4, -2. And let's do this one. Reflection, the origin, right there is A. That means make the origin the midpoint of A to A prime. So you're going to be somewhere in here. So let's count. 1, 2, 3, 4, 1, 2. So you're going to go up 4, left 2. If you do that again, that's where you're going to land for a reflection and a point. Okay? So that's the path it's going to take. Straight through the point. Make it the midpoint. So A triple prime, that looks to be the point -2, 4. You see that reflection through the origin. You can just switch the sign of both the coordinates. All right, let's go to the next graph here. Rotate 90 degrees about the origin. Okay, so here's 2, -4. And, all right. So we could turn the paper. We could use slope. We could do all sorts of things. Here's what you need to know. Just a shortcut here. You got to go 90 degrees in a counterclockwise direction. Here's what you got to know. This is the 4th quadrant. Okay, they usually use Roman numerals. If you're traveling 90 degrees, you're going to end up in the 1st quadrant. Okay. The other thing you got to look at, to get back to the point we reflect through, your rise is going to be 4, your run's going to be 2. We know it's -2. Basically, all you got to do for 90-degree rotation, you got to switch those. So if your rise was 4 for this one, your run's got to be 4 for the other one. 1, 2, 3, 4 from your center. All right. And all right, if we go down 2, it's going to take us to the wrong quadrant. So we know that's not right. If we go up 2, look at that. Look how easy it is. It's going to take us to the correct quadrant. That looks to me like a 90. I think we're going to go with it. Okay, so that's going to be, I'm going to stop doing the primes. I'm going to call it A sub 4. Okay, so A sub 4 is the point 42. A sub 4, we're going to say the point 42. All right, rotate 90 degrees about the point 31. Now, this is going to be a little more interesting here. Let's, okay, let's go back to this graph right here. Go ahead and graph 2, -4. There's A. And now we're going to go through the point 3. Let's call it P. We're going to rotate 90 degrees about that point. One of the tricks we could use is you could still turn the paper, but if you're going to turn the paper, you got to imagine that that is the new sort of origin, so to speak. Basically, what you're going to do is you're going to count from A to here now. Right? If you do that, it's over 1. So the run is 1. 1, 2, 3, 4, 5. The rise is 5. The 90-degree rotation. Okay, we're in basically, if you consider this the new origin, basically you're in your 3rd quadrant. You're going to move to the 4th quadrant, 90 degrees. You're going to move this way. Now, if your run was 1, your rise was 5, okay, you've got to switch it. You're going to go a run of 5 and a rise of 1. Now, you got 2 choices. You can go here or here. Now, which one's going to take to the next quadrant? Well, it looks like this one is. So that's the one. That's it right there. The A sub 5. Now, when we read the coordinates, of course, we got to go back to the real origin. And it's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's going to be a sub 5. We're going to call it a 0. Tough problem. You can check it out. The more mathematical way, of course, is to use slopes that are negative reciprocals. Sometimes we do things we just gotta get it right. Okay. We'll do the same problem here. 180 about 180. Just remember, you're making a straight line. 180 is a straight angle or a straight line. Okay. Technically, it goes this way because it's counterclockwise, but it won't matter. Let's start here. Instead of worrying about the switching the slope, whatever, we're going to use the same slope. So we want to make a straight line. So it's over 1, up 5. Do it again. Over 1, up 5. And there's a sub 6, it looks like. Back to the real origin. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So it looks like a sub 6 is 4, 6. Okay. Keep going. On reflection of line x equals 0. X equals 0 is the same. It's a vertical line. And it's the same as the y-axis. Okay. So if we take A, and reflect it in the x-axis, we're going to go 1, 2. We're going to go right back here. That's going to be negative 2, negative 4. So that's going to be a sub 7. And that's it for that one. All right, that's it for the first video. I will put up a few more to finish the rest of the review packet.